these are your 3-2 notes. Okay, so first, right here, monomial. Monomial is one term. All right. Example would be x squared, 3xy cubed, 1/2 x to the 4th. Okay. It's one term. Any variables would be together by multiplication. Okay. All right. You cannot have, if you have a variable in the denominator, it is not a monomial. We'll go over that in a little bit. All right. Can't have negative exponents. Polynomial is more than one term. Okay, for example, 2x plus 3y, x squared plus 3x minus 5. Okay. First example, that would be a binomial. Second example, that would be a trinomial. All right, but they're all polynomials. Okay. Degree of a monomial is the exponents of the monomial added together. So for example, 2x squared, the degree would be 2. 2x squared, y squared, the degree would be 4, okay? All right, you add the exponents together. 2x squared, y squared, z squared, the degree would be 6, okay? The degree would be 6. Degree of a polynomial is the biggest degree of any single term in the polynomial. Okay. For example, if we had 3x squared plus 4y plus 6z cubed, the degree of that polynomial would be, wrong button. Wrong button. The degree of that trinomial polynomial would be 3, because that is the highest degree of any single term in that trinomial. Another example here, 3x squared, y squared plus 4y plus 6z cubed. Okay. The degree of the first term would be 4. The degree of the second term would be 1. The degree of the third term would be 3. So the degree of the whole polynomial would be 4 there. He added them all up. Leading coefficient. The number in front of the variable with the highest degree. So it's from standard form, the first number. Okay. So in this case, 2 would be the leading coefficient. And then we have like terms. Terms with the same variable and exponent. All right, so next part here, determine whether each expression is a polynomial. If not, state why not. So a key here is it is not a polynomial if the exponent is negative or a fraction, okay? Has to be an integer. It can't be negative or a fraction. Has to be a positive integer. All right? Shh. All right? And you cannot have a variable in the denominator. All right? And then 2, all right, a monomial is a type of polynomial. Like a monomial, binomial, trinomial, they're all types of polynomials. So don't say it's not a polynomial because it's one term. All right. Number 1. Do you think number 1 is a polynomial? Yes. Yes. It's 2 terms. It is. And what are the exponents of both terms? 1. Do you think number 2 is a polynomial?
Yes. I say yes.
It's not.
What? No. Was there not a 1 in front of that?
It is not, because the square root of x is the same thing as x to the 1/2 power. Okay? X to the 1/2 power. And the reason That is, I'm going to make sure, is because when you have the square root of x, all right, the exponent inside the radical is 1, and then the index number is 2. And so taking it out of radical form to exponential form, which we will do more of, that 1 becomes the numerator over that index number becomes the denominator. X to the 1/2 power. And again, for it to be a polynomial, the exponent has to be positive. It cannot be a fraction. It has to be a positive integer. Yes, Bowden? Number 3, do you think that that is a polynomial?
A monomial, so yes.
Yes, good. What would be the degree of that polynomial or monomial?
2, yeah.
3.
3, good. 2 plus 1.
Oh, I got the one. Oh.
2 plus 1 give you 3 there.
Wait, how is it a polynomial?
Monomial is a type of polynomial, like binomial, trinomial. They all have their individual names.
4 is yes.
4 is yes. Good.
Degree 1.
Degree 1. Good. 5. Is 5 a polynomial? No, it is not. All right. The reason why it's not is if you bring z up to the numerator, okay, if you bring z up to the numerator, that makes that z to the negative first power. You cannot have negative exponents for it to be a polynomial. So that would be no there. We've really done this before, but okay, same thing as when we were doing the complex numbers here. If we're subtracting polynomials, right here, we're going to add, subtract, and multiply polynomials. So subtracting here, again, to prevent mistakes, it helps to distribute that negative so that we have 6x squared minus 3x plus 2 minus 4x squared minus x plus 3. Okay, that will help you prevent mistakes there. 6x squared minus 4x squared would give you 2x squared. Negative 3x minus x would give you negative 4x. And then 2 plus 3 would give you 5. Once you get that down, do number 3. 3. Distribute that negative. Negative 4m squared minus 6m minus 6m minus 4m squared. So that will give you negative 8m squared minus 12m.
Oh, give me that.
Good job.
I got it.
All right, number 5, we're combining like terms. We just have to add and subtract fractions. I know that is so hard, and I know it is scary, but we can do this.
My mom says that fractions is her favorite.
Fractions are fun.
No, they're not.
Fractions are fun. All right. 1/4 x squared minus 3/8 x squared are like terms.
Negative 1/8. Yeah.
So we want to make 1/4 2/8 common denominator. Yep. Subtract, and that will give us negative 1/8 x squared. Very good. Those of you who said that out loud. Next, we got xy's. We have a negative 3/8 xy, negative 1/2 xy. So we want to make 1/2 4/8 or negative 4/8. So we'll have negative 3/8 minus 4/8, which gives us negative 7/8 xy. Last, I'm doing y squared. 1/2 y squared plus 1/4 y squared. I'm going to make 1/2 2/4 plus 1/4, which gives me 3/4 y squared.
I'm reading something.
All right, so remember, standard form, we go by degree and then alphabetical order. All 3 terms have a degree of 2 there, okay? So we'll go alphabetical order. X squared, or x, and then xy, and then y. Here are the answers to 2, 4, and 6. Stop talking. Stop talking.
How did you know?
Answers 2, 4, and 6.
I got it right. The heck?
Let's go.
Is number 2?
Well, I got them all right.
Yeah, I got it right.
Why should it equal sign?
I need a Zion.
Because I put it into standard form.
Okay. Wait
I
a
think you're
minute.
wrong.
I think I'm right. I know I'm right. The next section here, we're practicing multiplying polynomials here. So for 7, we have a monomial times a binomial. So all I'm going to do is distribute. The key here on all of these, each one of these we're doing distribution techniques. So here we're distributing the 2x to 3x squared, which that would give us 6x cubed. Remember, we add exponents when we multiply. And then 2x times negative 5 would give me negative 10x. Number 8, we distribute the 7a to all 3 terms, right? It's a monomial times a trinomial, okay? So 7a times 6 gives me 42a. And then 7a times negative 2a would give me negative 14a squared. And then 7a times negative a squared would be negative 7a cubed. All right, now in standard form, that would be negative 7a cubed minus 14a squared plus 42a. Now, if we were doing this on a quiz and it was set up and it wasn't in standard form, I would be fine with 42a minus 14a squared minus 7a cubed because that is the way it's set up for the distribution, okay? But I did go ahead and put that in standard form just to stay on that trend, okay? Number 9, we have a binomial times a binomial. Lydia, what distribution technique do we use when we have a binomial times a binomial? That was pretty good. I thought you could say it better, a little bit better than that. All right.
Foil?
Harper, say foil for me. There you go. Thank you. Thank you, Harper. Foil. You got to foil it. All right. So here we go. Shh. We got to foil first. X to the 4th. Outer. Negative 5x squared. Inner. Negative 2x squared. Last plus 10. So we got x to the 4th. We need to combine like terms in the middle there, which will give me negative 7x squared, and then plus 10. Okay. Do we have any questions? All right, so number 10 and 11. All right, a little different. All right, in my experience, some people do struggle with these a little bit. All right, but just the key here is just take your time. Don't try and be fast. What we want to do when we have a binomial times a trinomial, Colin, is we want to distribute both terms in the binomial to each term of the trinomial. So I'm going to take x and I'm going to distribute it to all 3 terms. So I'll have x times 2x squared, which gives me 2x cubed. X times negative 3x, which gives me negative 3x squared. And then x times 1 gives me x. All right. Then I'll take the 1 and distribute it to all 3 terms of the trinomial. Okay. It's really like the way I do the distribution, right? It looks similar to foiling, except now you just have another term. But so when you multiply by 1, that just gives you 2x squared minus 3x plus 1. Then from here, we will combine our like terms. 2x cubed, there's only one variable with an exponent of 3. We have negative 3x squared and 2x squared, which would give us negative x squared. We'll have x and negative 3x. That'll give you negative 2x. And then 1. All right, I want y'all to do number 11. Then I think this is on... No, it is right below there. All right, then after you get done with 11, give the degree of 7, 8, 9, 10, and 11 right here, right? 7, 8, 9, 10, and 11. You're giving the degree in those blanks.
What is it? 1, 2, 3, 4, 5, and 6?
6, 7.
Oh, this one.
6, 7.
Yes.
Siete. I like that.
That's still we talking about.
Really?
I can count to 100.
Say siete. No way.
I can.
You're in Spanish 3 honors and you can count to 100?
Yep.
In English or in Spanish?
In Spanish.
Now you're.
I don't feel like
I
it.
think we should count. It's not class.
I think you should count.
I'll do it.
No, for bench.
All right. Ready, set, go. Uno, dos.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
I dropped
Yeah,
no, one more thing.
All right. Hey, work. All right, that's good. But y'all are not. It did. But y'all are. I was fine with it, except y'all are all looking at me instead of doing your work. Do your work.
You should at least let us get to 67.
I dropped it.
Start at 60.
I don't say six, that's this is una, this is
You're
dos,
really
this
just
is
gonna know
tres,
Siete, siete.
Sounds like a cold.
What would y'all do if on the exam I had like 4 answers in a row that were 6, 7?
That would make me
I would start like questioning
I would
myself.
start second guessing myself.
I'll start like slacking my.
There's no way for it.
Once I get more than 3 seasons in a row, I say we're wrong.
I would not be able to contain my laughter.
I will. I will definitely have at least one answer of 6, 7.
No, but this way, our test had 5 C's in a row as the answer.
Yo,
Like,
no.
The last
Oh
page.
yeah, the last.
The whole
Last
last
page.
page.
the last page was C.
That's kind of evil.
I don't hope that's not in
Is that not evil? That is so evil. Because I start second guessing myself.
After like 3, I'm like, this is wrong.
See, I don't let things like that bother me. You know, I leave the past in the past. I move on. You know.
Good matter was that.
Like, after like
Raise your hand if you're done.
8.
See, because your name Riz King, I don't get it.
Colin, work.
Why did East call you Riz King?
I just asked if you were done, and you know.
I didn't give me the L with the yonder mouth.
Maddox, are you done?
Yep.
I'm not.
What pressure on this one? Good job, Z.
I think I'm done now.
Thank you.
How are you gonna be able to keep up?
Somebody find out who said it.
Thank you. Thank you.
All right, here you go. Here are the answers. Yes, go ahead, and you need to write all of this out and copy it down onto your notes, and then we're done.
That made me giggle a little, Carter.